Good evening, viewers of Akshi.com by Vetri from Pondicherry. Today, I am going to discuss another most important chapter, qualitative and quantitative analysis of organic compounds. Under the qualitative, I am going to discuss detection of elements, carbon, hydrogen, oxygen, nitrogen, sulfur, halogen, phosphorus, etc. The same way, under the quantitative analysis also, I am going to discuss regarding the estimation of these elements present. The most important interesting information here is, so before doing this qualitative and quantitative analysis of organic compounds, we have to test the purity of the sample. So let me discuss. So today, under this heading, qualitative and quantitative analysis of organic compounds, I am going to discuss three headings. One is detection of elements, number two, estimation of elements, and number three, determination of empirical and molecular formula if time permits. Okay. First, qualitative analysis of organic compound, that is detection of elements. I am going to discuss. So under this, first one is test for purity. Under this, detection of carbon and hydrogen, detection of nitrogen, detection of sulfur, detection of halogens, and detection of other elements like phosphorus, oxygen, etc. So this I am going to discuss today under qualitative analysis of organic compounds. Test for purity. This is the most important because our aim is we have to determine the empirical formula and molecular formula. To determine accurately, so we need to test the sample is pure or not. So what is the test available to identify the purity? Suppose some organic compound can be classified into three ways. One is solid organic compound, liquid organic compound, and gaseous organic compound. Suppose if it is a solid, what way we will test the purity? So by taking melting point, by determining specific gravity, etc., we can determine the purity of the sample. Because melting point is a characteristic of any solid. So if it is impure, it will not be sharp. If it is 100% pure, we will have a sharp melting point. The same way, for liquids, boiling point and density are the characteristic property. By measuring, we can determine the sample it is pure or not. So we know already what is boiling point. Boiling point is the temperature at which the vapor pressure is equal to atmospheric pressure. The water boiling point is 100 degrees. If it is pure, boiling point will be 100. If it is impure, boiling point will vary. So liquids can be tested for purity by noting boiling point, density, etc. The same way, gases, impurity of a gas can be tested by diffusion rate. Okay, let me discuss. First, let me discuss detection of carbon and hydrogen together. Okay, under this, what are the things I am going to discuss? So, normally, what is the basic principle involved? I must discuss. Then experiment, what is the procedure? Then a reaction. I have to discuss under each heading. So, let me discuss now. So, what we are saying here, the apparatus used for carbon, detection of carbon and hydrogen. So, when organic compounds, it is heated with dry copper oxide, normally 2 to 3 times, excess of dry copper oxide. When you heat, what will happen now? If carbon is present, will be converted into carbon dioxide. If hydrogen is present, it will be converted into water. This is the basic principle. So by testing the presence of carbon dioxide and by testing the presence of water, we can able to say there is carbon, there is hydrogen. So here the apparatus used, what we are seeing here, a hard glass tube. This is the part containing a mixture of organic compound plus excess of dry copper oxide. Then which is connected to that is a tube having anhydrous copper sulfate. Anhydrous copper sulfate is white in color, and that is connected to a jar, that is the flask containing lime water. So which is again connected outside another that is tube containing anhydrous calcium chloride. that is called God tube, which is end is just blocked with the cotton block. Okay, this is the apparatus. So what is the actual procedure? So take a known quantity, that is a small amount of organic substance, and take excess of dry carbon oxide in this tube, glass tube. Then here in this flask we are taking lime water. Here in this case, that is anhydrous calcium chloride. So in this case we are taking anhydrous copper sulfate, which is white in color. Okay. Now when we are starting the experiment, heat strongly with the help of a burner. So what will happen now? Carbon present will be converted into carbon dioxide by copper oxide. Same way hydrogen present will be converted into water by copper oxide. So when these vapors, that is carbon dioxide gas and water vapors, are passing through here in this particular stage, now the anhydrous copper sulfide will absorb water molecules, converting into, that is the corresponding, will absorb water. After absorbing, the anhydrous copper sulfide, which is white in color, will become blue color. So blue color, formation of blue color shows there is water formation. If there is water formation, we think of the correspondingly the presence of hydrogen. The same way here, after the carbon dioxide gas, when it is allowed to pass through the lime water, if lime water turns milky, it shows there is carbon dioxide. If there is carbon dioxide, it indicates there is carbon. So this is the way we can read the procedure part. Okay. Now this is the specific reaction, kindly go through. So carbon present in the organic compound, when we are treating with the copper oxide, excess, in this case 2 times I am giving, so converted into carbon dioxide and copper is liberated. So carbon dioxide gas is formed. The same way, what will happen? This carbon dioxide gas, when it is passed into lime water, that is calcium hydroxide, which turns lime water milky, that is converted into calcium carbonate, a precipitate. That's why we are seeing it as a lime water turning milky. This is the characteristic reaction. First case. The second case, the hydrogen present in the organic compound, when we are heating with the copper oxide, converted into water and the copper is liberated. So what will happen? The copper is again deposited. So what will happen now? This water, excess water, when it is vapors, when it is passing through anhydrous copper sulfate, which is colorless, after absorbing water molecule, 5 water molecule become hydrated copper sulfate, that is blue color. So formation of blue color indicates there is water. So there is water means there is hydrogen. So this is the way we can detect carbon and hydrogen present in an organic compound. This is the way we can detect the carbon and hydrogen. Okay, let me go further. Next is detection of nitrogen, sulfur, halogens, etc. all other elements using a specific test called a Lenzini test. This is the most important. Lenzini test. Lenzini test. That is, so what is Lenzini test? In this test, we are going to prepare sodium fusion extract. Sodium fusion extract. Preparation of sodium fusion extract, nothing but, and using this extract, we are going to detect a number of elements, and this test is called a Lenzini test. Okay. Here, what we have to do is, if it is a solid or liquid, what we have to do, take a dry metallic sodium, piece of dry metallic sodium. Normally, we are preserving it in kerosene, chemically inert solvent, normally kerosene. So by taking out this small piece of dry metallic sodium, dry by pressing it through the filter paper, and then introduce in a fusion tube, then along with a little substance, organic substance, heat strongly. When it is heated strongly, what will happen? If carbon along with nitrogen is present, converted into sodium cyanide. The same, if sulfur is present, converted into sodium sulfide. If a halogen is present, fluorine, chlorine, bromine, etc., will be converted into sodium halide. And if there is any presence of oxygen, converted into sodium phosphate. So these are the real chemical reaction that is taking place in Lenzini test in the sodium fusion extract. So after introducing this, after heating now, this extract, now what we have to do now? We have to take this dry fusion tube. After heating strongly, it turns red hot. Then plunge it in a mortar containing little water. Then grind it. Take the extract, boil, filter, and keep. This is called sodium fusion extract. Kindly follow. So with this sodium fission extract, we have to test for nitrogen, sulfur, halogen, phosphorus, etc. So let me discuss one by one. First, let me take detection of nitrogen. So under the detection of nitrogen, so what is the actual procedure I have to follow? So take 1 ml of sodium fission extract. Kindly follow. Take 1 ml of sodium fission extract. Then to that add freshly prepared ferrous sulfate solution. Freshly prepared ferrous sulfate solution. Heat strongly. Cool. To the cooled solution add the neutral ferric chloride followed by acids. So immediately the formation of a blue or bluish green or green colored solution or precipitate shows the presence of nitrogen. This is the interesting information. So this is the way. So formation of a blue color or bluish green color or green color solution or precipitate shows the presence of nitrogen. So that's nothing but it is due to the formation of Prussian blue. Prussian. Another name, chemical name for that, ferric ferrocyanide. Okay, let me explain the chemical reaction involved there. So in the sodium fission extract, I have already pointed out to you, when sodium is heated with the organic substance, then carbon and nitrogen is present, converted into sodium cyanide. So in sodium fission extract, sodium cyanide is present. This is very interesting. Okay, when you are adding 1 ml of sodium fission extract, freshly prepared ferrous sulfate. I am using freshly prepared ferrous sulfate because suppose we are preparing a solution, ferrous sulfate solution, and if you are keeping in the room temperature for 1 week or 1 month, now it will be getting oxidized by air. So after air oxidation, ferrous sulfate will be converted to ferric sulfate. If you use that solution prepared before 1 month or 1 year, then automatically this reaction will not answer. This test will not answer. So that's why I am specifying you have to use whenever you want to test, prepare solid and then prepare freshly prepared ferrous sulfate solution. Okay. In the second step, when you are heating with the sodium, that is the sodium fission extract and ferrous sulfate, the double decomposition reaction, that is here, ferrous cyanide and sodium sulfate is formed. So this is the second step. In the second step, ferrous cyanide is formed, FeCN2. FeCN twice it is forming ferrous cyanide. And to the above solution, now again because this excess of again sodium cyanide is present there in the solution, so combine again to form sodium ferrocyanide, Na4 FeCN6. Sodium ferrocyanide is formed. So in the second step, when we are adding ferrous sulfate, freshly prepared ferrous sulfate to the sodium fission extract excess, so we are getting this sodium ferrocyanide, a complex. It's a coordination compound. Right. To that solution, now if you add neutral ferric chloride versus one acid medium, so this sodium ferrocyanide will be converted into ferric ferrocyanide. Formula is Fe4 FeCN6 thrice. This is called ferric ferrocyanide. Another name, common name is Prussian blue. I have already pointed out. So the formation of blue, bluish green or green color solution or precipitate is due to the formation of ferric ferrocyanide or Prussian blue. Kindly follow. Question can be asked. That is the most important information. So if there is any formation of color or solution of blue, bluish green or the green, that shows there is nitrogen. So that nitrogen is due to the presence of ferric ferrocyanide. So here I want to give one important information. Kindly follow. So normally question can be asked, even in IIT question asked, one among the following compounds will answer for nitrogen. One among the following compounds will not answer for nitrogen test. The most interesting information, kindly follow. To answer the nitrogen test, it is necessary nitrogen, that's no doubt. But without any carbon in the organic compound, it will not answer because it has to convert into sodium cyanide. So to form sodium cyanide, we need carbon. So simply if you take a hydrogen, a compound like a hydrogen, organic chemistry, you know that. NH2 compound is called hydrogen. If you take this compound, if you try, it will not answer because there is no carbon. So question can be asked. So you should be very careful. So this is the way we can detect the presence of nitrogen. Okay, the next thing is, when we are testing for nitrogen, if there is sulfur also, we have some problem. So let me explain that problem. So detection of nitrogen presence of sulfur. What will happen? So when we are doing this test for nitrogen, that is formation of Prussian blue, suppose if sulfur is present, we will not get blue or bluish green or green color solution or precipitate, because the color will be masked by sulfur. That will be normally if the blood red color will form. So formation of blood red color will spoil the entire color. We cannot be able to detect the present nitrogen present or not. So what is the idea here? It is, suppose along with the carbon nitrogen, if sulfur is also present in the sodium fission extract, the correspondingly sodium sulfur cyanide will form. So in the sodium fission extract, sodium sulfur cyanide will be there. So when we are adding neutral ferric chloride to the solutions, so what will happen? Along with Prussian blue, this compound ferric sulfur cyanide is also forming. FeCN thrice. Ferric sulfur cyanide, which is responsible for blood red coloration. So this blood red coloration will mask the color, blue color or green color. So we will see only a blood red color. So you students, you should be very careful. Suppose when we are testing for nitrogen in presence of sulfur in your laboratory, so if there is any blood red coloration, you should be very careful, because it will mark the detection of nitrogen. Okay, the next one. So detection of sulfur. Let me discuss next. How will you detect the presence of sulfur? I will discuss. So as usual, so we have in the rasainic test, we are preparing a sodium fission extract. Again, take 1 ml of sodium fission extract and then we can divide it into 2 portions and we have to test. So first test is, we'll call it a sodium nitroprusside test. This is a very, very sensitive test and most important test also. What is sodium nitroprusside test? Take just 1 ml or less than 1 ml of sodium fission extract, add just 1 drop of sodium nitroprusside. Formula Na2FeCN5 CN5 times. Sodium nitroprusside, because we find NO. So Na2FeCN5 CN5 times NO. This is sodium nitroprusside formula. So when you add just 1 drop, immediately formation of violet color indicates the presence of sulfur, because this complex is formed. The complex is Na4 FeCN5 times NOS. Simply just see, when you compare these two structures, you will have the sulfur is introduced here. That is the only difference. So formation of this complex will show violet color. So very, very simple and sensitive test. To 1 ml of sodium fission extract, add just 1 drop of sodium nitroprusside. Then if there is formation of violet color, there is sulfur. That's all. If there is no violet color, sulfur is absent. This is a very sensitive test. Now, to the second portion of sodium fission extract, I will conduct another test called lead acetate test, again for sulfur. What is that test? So now again, you take the 1 ml of sodium fission extract and then add equal quantity of lead acetate. Lead acetate, then add a few drops of the glycolic acid, heat strongly. So when we are heating, what will happen? Now you will get correspondingly a lead sulfide, a black precipitate will form. This is the most interesting information. So formation of a black precipitate shows the presence of sulfur. So along with sodium acetate is formed. This is the interesting information. So sodium fission extract is containing sulfur. So when we are heating with the lead acetate in presence of glycolic acid, now the sulfur will be combining with the lead to convert into lead sulfur, which is a black precipitate, producing black precipitate. So formation of black precipitate shows the presence of sulfur. This is second test. So sulfur can be tested by 2 ways. One is sodium nitroprusside test, another is lead acetate test. By these 2 ways, presence of sulfur can be confirmed. Okay, next one. Detection of halogen. Next is halogen can be detected. That is fluorine, chlorine, bromine, iodine, etc. can be. As usual, what will happen when we are preparing sodium fission extract under Lasaini test? If there is any halogen, will be converted into sodium halide. Sodium halide means sodium fluoride, sodium chloride, sodium bromide, sodium iodide. So in the solution, the sodium fission extract, they will be in the form of sodium salt. So take 1 ml of sodium fission extract and dilute nitric acid, that is heat strongly. After heating, add silver nitrate solution. Then there will be a characteristic precipitate will form. AgX will form. That a characteristic precipitate will form. And to that precipitate, add ammonium hydroxide solution. So then, depending upon the activity, then we can identify maybe chlorine, maybe bromine, or maybe iodine. So the characteristic precipitate here shows the presence of halogen. Let me repeat again. So to 1 ml of sodium fission extract, we have to add a few drops of dilute nitric acid and we have to heat strongly. After heating, cool the solution. To the cooled solution, we have to add silver nitrate. When we are adding silver nitrate, a silver halide will form. So depending upon the nature, chlorine means white, bromine means light yellow, and iodine means the dark yellow. Precipitate will form. So from this color of the precipitate, we can be able to see whether it is a chlorine, bromine, or iodine. The another interesting information I want to give here, kindly follow me. Suppose if the organic substance it is present, nitrogen is present, and sulfur is present, it will mask again. The color will be masked by this formation of sodium cyanide, sodium sulfur will mask this. So in order to avoid this only, we are heating with dilute nitric acid. When we are heating with dilute nitric acid, cyanide with this nitrogen will be escaped in the form of sodium cyanide. So when you are treating with dilute nitric acid, it will be escape in the form of SCN gas will go out. The same with the case of sulfur, in the form of H2 gas will escape, leaving only the halide. So we can get this one easily. So that is the interesting information. Okay, now can you follow? Now this is a table giving very clearly how to differentiate chloride, bromide and iodine. So suppose during the sodium fission extract, what we are doing to 1 ml of sodium fission extract, we are adding dilute nitric acid, heating, boil, after boiling, cool. To the cooled solution we are adding silver nitrate. So when we are adding silver nitrate, suppose if there is a white precipitate is formed, then we are adding ammonium hydroxide, freely soluble. Immediately the white precipitate, freely soluble in ammonium hydroxide shows there is chlorine. That is in the form of chloride, Cl minus, sodium chloride. So Cl minus will be present, chloride. The same, suppose if the precipitate is a pale yellow color and it is sparingly soluble in ammonium hydroxide, sparingly means partially. Sparingly soluble in ammonium hydroxide, it shows bromine. The same way, suppose if the precipitate is in yellow, dark yellow color, and it is insoluble in ammonium hydroxide, shows iodine. This is the interesting information. Again, can you follow me, students? Question can be asked. So white precipitate freely soluble chloride, pale yellow precipitate sparingly soluble ammonium hydroxide shows bromine, and dark yellow precipitate insoluble in ammonium hydroxide shows iodine. So this is the way we can detect the presence of halides. The another interesting information regarding halides, the specific test is called the Beilstein test. Can you follow? Sometime question can be asked. What is Beilstein test? So we have to test the presence of halide with the help of a copper wire. The copper wire will be, one end will be blended with a wire. So what we have to do now, take this copper wire and throw them over the flame, oxidized Bunsen flame, until there is no green color, anything, nothing. Now take it out the copper and insert into our halide. So some amount of substance will be attached to the blended end, again show over the flame. Now if it is giving a green color, that shows there is halogen. Can you follow? So this is the presence of halogen can be detected by Beilstein test. That's called copper wire test. But one drawback, even though this is sensitive, there is a drawback. There are some compounds without containing halogen also will answer. A specific example, urea. When you use urea, again it's giving green color, but it's not containing halogen. Can you follow? Urea formula, NH2, CO, NH2. This is giving character, this color character is green color for this. But anyhow, this test is sensitive test, you must know. So Beilstein test is used normally to detect the halogen. The question can be asked based on this. Next, let me go for detection of phosphorus. This is another interesting element we can. So when we are preparing sodium fission extract, we already discussed under the Lenzini test. So what will happen now? If phosphorus is present, it will be in the form of sodium phosphate. In sodium fission extract, sodium phosphate will be there, kindly form. Now what will happen now? To the 1 mole of sodium fission extract, now add nitric acid, that is, then heat strongly. When you are adding concentrated nitric acid and heat strongly, that sodium phosphate will be converted into phosphoric acid and sodium nitrate will form. Now, into that above solution, after heating, cool, and to the cooled solution, we have to add ammonium molybdate solution. Ammonium molybdate formula is given NH4 twice, MoO4, ammonium molybdate. So when we are adding ammonium molybdate solution, immediately a yellow precipitate of ammonium phosphomolybdate will form. If there is any yellow precipitate formation, it shows there is a presence of phosphorus. Very, very interesting information. So in this equation, so when you are treating with nitric acid, phosphoric acid is formed. That phosphoric acid, when you treat with the ammonium molybdate, so it is converted into a complex. It is ammonium phosphomolybdate is formed, which is responsible for our yellow color, shows so that the presence of phosphorus can be detected. This is a very, very interesting test for phosphorus. Okay, next one. Reduction of oxygen. Normally, oxygen will not detect directly because it's very, very difficult, because even the entire atmosphere is containing oxygen. So there are different ways we will trace. One is, we will test for the functional groups containing oxygen. So what are the functional groups? Alcoholic group OH, acid group COOH, aldehyde group CHO, nitro group NO2, etc. We will test, and if they are answering, then we will say there is hydrogen. This is one way. In another way is, when we are discussing, we are going to discuss the estimation. Under the percentage determination, if you add all the element percentage, if it is less than 100, then we will conclude there is something. So these are the way we will detect the presence of oxygen. Can you follow? So this is the way we have to detect the presence of element. The basic idea here it is. So only in the case of carbon and hydrogen, we are doing a special test, tricopper oxide test. But all other elements, nitrogen, sulfur, halogen, phosphorus, etc. So we have to use called Lenzini test. Under the Lenzini test, we have to prepare sodium fission extract. From the extract, we have to test. I hope you have enjoyed the detection of elements. Let me go to the second part, that is estimation of elements. Under the estimation of elements, I am going to discuss estimation of carbon and hydrogen. Number 2, estimation of nitrogen. Number 3, estimation of sulfur. Number 4, estimation of halogens. And number 5, estimation of other elements like phosphorus, oxygen, etc. So let me go one by one. First let me take estimation of carbon and hydrogen. This is the most important. So under the estimation of carbon and hydrogen, again, I am going to discuss 3 ways. One is basic principle involved there, the experimental part, that is procedure, and then calculations. So I will discuss one by one systematically. What is the basic principle involved? When any organic compound containing carbon and hydrogen, when we are heating with copper oxide, excess copper oxide, then the carbon, if it is present, will be converted into carbon dioxide, and hydrogen, if it is present, converted into water. So from the amount of carbon dioxide formed and the amount of water formed, we can determine the percentage of the corresponding carbon and the hydrogen. We can estimate the percentage of carbon and hydrogen. So this is the basic principle involved. So here I have given a general formula, that is correspondingly CXHY plus O2 giving XCO2 plus half YS2. This is a general formula. Specific example, methane. So methane, when you burn in presence of oxygen, corresponding carbon dioxide 1 mole and 2 H2O it is formed. This is the interesting information. This is a general reaction. But how we are getting oxygen? That is coming from copper oxide. We are using. This is the basic principle involved. Coming for the experimental part. So the apparatus here consists of 3 parts. One is oxygen supply. Number 1, part 1 is oxygen supply. The number 2 is the entire tube, that is combustion tube, and third part is absorption unit, absorption of carbon dioxide, absorption of water. So there are 3 parts of apparatus. Okay, so what is actually the basic principle here? That is, I have discussed already basic principle, and what is the procedure we have to follow? Kindly follow. Take a known quantity of organic substance, let it be W grams, say for example. Now, so we have to heat in presence of copper oxide using a fire, that is the combustion tube, special apparatus combustion tube, normally approximately 33 inches or let me say 90 centimeter length, 1 or 2 centimeter diameter. Now this is a combustion tube we have to use. So before starting the experiment, now what we have to do now, disconnect the combustion tube from the setup and heat strongly, pass that is pure oxygen, and remove any carbon dioxide inside, any moisture inside, and pass it out. Then you connect the setup, everything ready. So what will happen before entering this, the unit of this side, that is containing 100 calcium chloride very separately, the unit of potassium hydroxide U tube again very accurately, separately. Now connect the entire apparatus, keep it ready. Now we have to start the experiment. What we have to do now, introduce a W gram of organic substance in a platinum board inside, place it inside the combustion tube and heat strongly with the help of furnace. When we are heating, I have already discussed excess of copper oxide inside. So here in both sides, here and in this case, there is copper oxide, the extra copper oxide will be there. So what will happen again, copper oxide, so during this copper oxide, when you are heating, converting this carbon into carbon dioxide and hydrogen into water. So even backward diffusion will be prevented by the copper oxide gas and pellets. Right. So what will happen now, when we are heating, so carbon converted into carbon dioxide, hydrogen converted to water. And these vapors are passing through, so because we are passing hydrogen oxygen gas from the side, it will carry all the vapors. When they are coming here, under the first setup, anhydrous calcium chloride. So now what will happen? It will absorb water. Okay, again it is, so the carbon dioxide without absorbing going here potassium hydroxide solution will absorb correspondingly carbon dioxide. Kindly follow. In this case, now what will happen now? With the weight of anhydrous calcium chloride tube and weight of potassium hydroxide tube will increase in weight. And from the initial weight and final weight, we know that from the difference we know amount of here water form and here carbon dioxide form we can determine. So from the weight of water formed and carbon dioxide form, we can able to estimate the percentage of carbon and hydrogen with the help of a Levy combustion method. Kindly follow. This method is called a Levy combustion method. The tube is called Levy combustion. This is the experimental procedure. Let me go for the calculations. So, kindly follow me. Mass of organic substance used, let it be W gram. That is, I introduced initially W gram in the combustion tube. Then, mass of water formed in the U tube, it is W1 gram, let us assume. Then, mass of carbon dioxide formed, let us assume W2 gram. So, only 3 readings we are having. One is simple compound used W gram, water formed W1, carbon dioxide formed W2. From these 3 readings, we are going to determine the percentage of carbon and hydrogen as follows. Kindly follow me. Percentage of hydrogen. 18 grams of water contains 2 grams of hydrogen. Therefore, W1 grams of water form. So, W1 grams of water contains 2 by 18 into W1 grams of hydrogen. So, I have used W grams of organic substance. So, W grams of organic substance contains 2 by 18 into W1 gram of hydrogen. So, 100 grams of organic substance contains 2 by 18 into W1 by W into 100. That's nothing but percentage of hydrogen is equal to 2 by 18 into W1 by W into 100. W1 weight of water form, W amount of organic substance used. Next, percentage of carbon. the carbon dioxide, the molecular formula CO2. So 4 grams of carbon dioxide contains 12 grams of carbon. So W2 grams of carbon dioxide contains 12 by 44 into W2 grams of carbon. So we have used W grams of organic compound. So W gram of organic compound contain 12 by 44 into W2 gram of carbon. So 100 grams of carbon dioxide contains, 100 grams of organic compound contains 12 by 44 into W2 by W into 100. That is nothing but percentage of carbon. So percentage of carbon is equal to 12 by 44 into W2 by W into 100. So this is the way we have to determine the percentage of carbon. I hope I have given the how we have to determine the percentage of carbon and hydrogen I have discussed. Let me go for the next step, the estimation of nitrogen. That is how to determine the percentage of nitrogen. Let me discuss now. So nitrogen, percentage of nitrogen can be deducted by two ways. One is by Geldan's method, another is by Dumas method. Kindly follow. By the Geldan's method we can estimate the percentage of nitrogen, and by Dumas method also we can determine the percentage of nitrogen. So let me discuss one by one. First one, let me take Geldan's method of determining estimation of nitrogen. Okay, again as usual, basic principle involved here, experiment procedure and calculation. And what is the basic principle is, when any organic substance containing nitrogen, so we have to heat strongly with the corresponding concentrated sulfuric acid in presence of potassium sulfate and copper sulfate. So that will be converted into ammonium sulfate. Nitrogen will be present, the organic will convert to ammonium sulfate. When this ammonium sulfate is treated with sodium hydroxide, that will be converted into the correspondingly ammonia. That ammonia gas we have to pass into a known quantity of acid taken, and then after neutralization we have to determine the volume. So from that we can determine the percentage of nitrogen. From the volume of consumed, the correspondingly the excess acid, then we can determine the percentage of nitrogen. This is the basic principle. Okay, let me go further. So so we are taking organic compound containing nitrogen. So I am heating with concentrated sulfuric acid in presence of potassium sulfate and copper sulfate, and nitrogen will be converted into ammonium sulfate. This is the basic principle. What will happen now? Here potassium sulfate is used to regulate the boiling point. Copper sulfate is used as a catalyst. This is the most important information you must know. So concentrated sulfuric acid is now converting nitrogen into ammonium sulfate. This is the step 1. So what will happen now? This ammonium sulfate, when we are treating with sodium hydroxide, converted into ammonia. Sodium sulfate and water. So this ammonia gas we have to pass into a known quantity of concentration of sulfuric acid, standard acid, HCl or sulfuric acid. So where now from the volume consumed, the remaining amount of the unreacted acid, we have to do back titration with sodium hydroxide, and from the volume of acid consumed, so we can determine the volume of nitrogen, ammonia, and from the volume we can determine the percentage of nitrogen. This is the procedure. So let me follow here. So what we are seeing is the apparatus used, Geldal flask. Kindly follow. This is the special apparatus used for Geldal. So this is the Geldal flask, and here we are taking organic substance containing sulfuric acid, copper sulfate and potassium sulfate. So when you are heating, automatically this converting into ammonium sulfate. And then you open the Geldal flask and transfer into a round bottom flask with the help of Geldal trap, connect it to your condenser and a receiver. The receiver we have to take a known volume of standard acid. So when we are heating this, the corresponding content ammonium sulfate with the sodium hydroxide, ammonia gas is liberated. This ammonia gas is now coming. Kindly follow. So here we are taking a known standard acid. So for example, 100 ml of 0.1 sulfuric acid. So the ammonia will consume. After the entire gas is passed, the remaining unreacted standard acid we have to back titrate with sodium hydroxide. From this, we are going to determine the correspondingly percentage of nitrogen. Kindly follow the calculation. So weight of organic compound use W gram. Kindly follow. let it be, that is W grams of organic substance we are using. So we are getting one value. Another is volume acid used for neutralization, VML. VML of strength, N strength of acid, maybe 1 N, it may be 0.1 N, whatever it may be. So we are having weight of organic substance used W gram, the volume used for neutralization VML. So how we are determining VML? So we are taking a known concentration, and from the after consumption, the by bacterization unreacted we are determining. So from the total unreacted if we subtract, we get the volume consumed by ammonia, that is VML. Then strength of acid used N. So now the basic principle here it is, the idea here it is VML of N ammonia equal to VML of N acid. So basic this idea we are going to do the calculation as follows. So let us assume now 1000 ml of N ammonia solution contains 14 grams of nitrogen. So VML of ammonia contains 14 by 1000 into V gram of nitrogen. So we have used W grams of organic compound. So W gram of organic compound contains 14 by 1000 into V into N gram. So 100 grams of organic compound contain 14 divided by 1000 into V into N divided by W into 100. V, that is the volume of the acid consumed, that is ammonia consumed, N strength of the standard acid, W amount of the substance used. Therefore, percentage of nitrogen is equal to 14 divided by 1000 into V into N divided by W into, that is 100. So that is the percentage of nitrogen. That is 14 divided by 1000 into V into N divided by W into 100 will give the percentage of nitrogen. Okay, next one. Next I will discuss estimation of nitrogen using Dumas method. The first one is Geldon's method, the second one is Dumas method. Now, again as usual, basic principle involved here, experiment and calculation. What is the basic principle? That is, we have to take W gram of organic substance. Then the most important information here we have to use that is Libby combustion tube. So when you are heating with the Libby combustion tube, what will happen? The nitrogen present in the organic compound will be converted into nitrogen gas. And this nitrogen gas will be collected over the potassium hydroxide solution in Skipp's nitrometer. From the volume of that is nitrogen gas collected, we can determine the percentage of nitrogen. That is the basic principle. Okay, experimental part and calculation I will discuss. So this is the basic principle. Kindly follow the general formula is given. CXXY, N is a organic compound plus 2x plus y is y by 2 copper oxide. Arrow x CO2 plus y by 2 H2O give plus Z by 2 N2 plus 2x plus y by 2 copper. So actually we are getting the correspondingly nitrogen gas will be there. So from the nitrogen gas we can able to determine the percentage of nitrogen. Let me come. This is the apparatus we are using. The first part, that is the generation of carbon dioxide unit, and this is the Libby combustion tube, Dumas method, and here the third one is Skipp's nitrometer containing, that is the potassium hydroxide solution. Skipp's nitrometer. This is the apparatus. So what will happen now? As usual, kindly follow here. In this part, organic compound is a copper oxide plus organic compound. Left side copper oxide gas, as in the case of again carbonate hydrogen, and right side again there is a coarse copper oxide. In this here again reduced copper oxide to prevent again further reduced to any oxide from nitrogen converted to nitrogen gas. So when we are taking a known quantity of W gram and introducing this combustion tube, heat strongly with the help of furnace. So nitrogen present in the organic compound will be converted to nitrogen. If any nitrogen oxide is formed, that will be reduced by reduced copper. So this nitrogen gas will be passed over and collected over mercury. There is potassium, over that potassium hydroxide, the nitrogen gas will be there. So now this gas, volume of gas, by adjusting the reservoir, the volume can be adjusted. And from the volume at NTP, we can convert into the actual volume. From the volume of nitrogen gas collected, we can determine the percentage of nitrogen. This is the actually experimental part. Next one. So, calculation. Weight of organic compound used W gram. Volume of nitrogen gas collected at room temperature V ml. Temperature is T degrees centigrade. Aqueous tension at room temperature that is given by B. So volume collected at NTP is equal to small v into capital B minus B divided by small t plus 273 into 273 by 760. So V volume that is converted at NTP. The V small volume, that is the volume of nitrogen gas collected at room temperature. Capital B barometric pressure. B small b aqueous tension at room temperature, small t at temperature, room temperature. So by using this, so we can calculate the volume at NTP. So 22,400 of N2 gas at NTP contains 28 gram. V ml of N2 gas at NTP contains 28 divided by 22,400 into V. So W grams of organic compound we have used. So W grams of organic compound produce 28 divided by 22,400 into V grams of nitrogen. For 100 grams of organic compound produces, that is equal to 28 divided by 20,400 into V divided by W into 100. So V, that is the volume at NTP, W weight of organic substance used. So that is nothing but percentage of nitrogen is equal to 28 divided by 20,400 into V by W into 100. This will give the percentage of nitrogen. Let me go for the next is estimation of sulfur. Another interesting method. But estimation of sulfur, halogens, phosphorus, etc. we can use a special method called Carrier's tube. Again, as usual, I will discuss basic principle, experiment and calculation. Kindly follow. Estimation of sulfur. The basic principle involved here it is. So when organic compound containing sulfur, a known quantity, when you are heating with excess steaming nitric acid in a Carrier's tube, now what will happen in presence of that? So what will happen now? Then the sulfur will be converted into corresponding sulfate. So when you are treating with sulfuric acid, the corresponding barium sulfate will form. So that is when you add barium chloride, barium sulfate will be converted. Kindly follow. So organic compound containing sulfur, when you are heating with dilute nitric acid, after in a Carrier's tube, now then this tube after breaking we have to transfer into a beaker containing sulfuric acid, followed by you can add barium chloride. So barium sulfate will be precipitated. So from then we have to filter this barium sulfate and weigh accurately. From the weight of barium sulfate formed, we can determine the percentage of sulfur. This is the interesting. So we need only two readings. One is amount of organic substance used, W gram, and weight of barium sulfate formed, W1 gram. From these two readings, we can able to estimate the percentage of sulfur. Kindly follow. The idea here, this is the sulfur, we are using Carrier's tube. So this is the special apparatus called the Carrier's tube. So inside this, a known amount of organic substance we have to introduce in a special tube inside without disturbing, seal the tube, and then you can introduce in a furnace, electric furnace, the Carrier's tube, and heat strongly with the nitric acid. After this, sufficient time is allowed, break the tube, transfer into a beaker containing, then add sulfuric acid, then add barium chloride. Barium sulfate will be precipitated. From then barium sulfate once formed, filter that precipitate, dry, weigh accurately. From the weight of barium sulfate, we can estimate sulfur the following way. This is the calculation. So we are going to use now. So mass of organic compound used W gram. That is we are using. So mass of barium sulfate formed is W1 gram. Kindly follow. This is the only two readings we have. One is W gram of organic substance we used, and W1 gram nothing but mass of barium sulfate formed, precipitate formed. From these two readings, I am going to estimate the percentage of sulfur as follows. 233.4 grams of barium sulfate contains 32 grams of sulfur. From the barium sulfate molecular formula, we know it contains one sulfur, so 32 grams of sulfur. So 233.4 grams of barium sulfate contain 32 grams of sulfur. Therefore, W1 grams of barium sulfate, that is the amount of barium sulfate precipitated is W1 gram. So W1 grams of barium sulfate contain 32 divided by 233.4 into W1 grams of sulfur. So W grams of organic compound will produce so much, that is 32 divided by 230.4 into W1 grams of sulfur. So 100 grams of organic compound will produce 32 divided by 233.4 into W1 by W into 100, where W1 the amount of, that is the barium sulfate produced, precipitated, W the amount of organic compound used, so that will give the percentage of sulfur, that is the percentage of sulfur is equal to 32 divided by 233.4 into W1 by W into 100. So this is the way we can estimate the percentage of sulfur. So I hope you have enjoyed the lecture.